Good morning, all of you. Welcome back to the chemistry class. In the previous class of the chemistry, we have studied the interconversion of states of matters, and we come across the terms like melting point. Okay. We came across the term like freezing point. Okay. We came across vaporization or boiling, and we also come across the term boiling point. We have also studied about condensation and condensation point. Okay. Hope all of you have understood these four important terms related to the interconversion of states of matter: melting, freezing, vaporization, condensation. These all are actually a process. Okay. And this melting point, freezing point, boiling point, condensation point is actually the temperature. That is a fixed temperature or a constant temperature at which the interconversion of states of matter takes place. That is a constant temperature. This happens. Okay. We also have understood about where the heat is absorbed and where the heat is released. Today, my topic will be stick to the sublimation and deposition. Okay. What is sublimation and what is deposition? The another important term for interconversion of states of matter is sublimation. A very important term, sublimation. Actually, this is the process in which the solid state directly changes to gaseous state without coming to the liquid state. The process in which the solid state directly changes to gaseous state. Okay, here for example, solid is directly changes to gaseous state. Can you consider any example in which where we can find a solid changes into gases directly? One very basic example which you all can have is kapoor. Okay, that is kapoor. Okay, that is actually in Hindi we say kapoor. That is what we use it in our for doing puja and all. Okay, actually it is camphor. Okay, in English we say it camphor. That is white color, you can see, cylindrical shape. It is burned. When the heat is absorbed, the solid changes to gases directly. Okay, this is one of the example day-to-day life you can see. Okay, another is naphthalene ball. Naphthalene ball. Okay, naphthalene balls. Those white colored balls which your mother is using for keeping in to keep away the insects away. Okay, to keep the insects away. In naphthalene balls, you can find it in your almirah. Okay, in your trunk at the home, naphthalene balls are used. So what happens to these? They are the solid state actually, and they, without going to the liquid state, they directly changes themselves into gaseous form. So this is sublimation. And just opposite of this, what we are going to study, that is deposition. Okay. For example, also will be considered for that. Now we have another term, deposition. Although I think this term is not given in the book, but you need to understand. This is again the process in which the gaseous state changes to solid state directly. Okay, that is gaseous state changes into solid state directly. This is known as deposition. Sublimation and deposition, just opposite to each other. Okay, so these are the interconversion of states of matter which you all have studied all together. That is, now when we will complete the chart, for example, consider this. Now again the chart, consider the chart again: solid, liquid and gas. And if I put an arrow here, okay, now I will give each of them a name, that is A, B, C, D, E and F. Okay, now first of all I am giving all of you chance to write down each of these interconversion. C, D. Name them. Okay, which process is there that these can be named? Okay, what are the terms we can use here? That is, the solid changes into liquid, liquid changes into solid, then liquid changes into gaseous, gaseous state changes to liquid state, then solid state changes to gases directly, and gaseous state changes to solid directly. We have studied all the 6 types of interconversion of states of matter. So first of all, A. What would be the possible answer for the A? All of you see the arrow mark. And actually it is liquid to solid. Okay, liquid to solid. The arrow mark is here. So what? Now a liquid state changes to solid state. So what it will be? It will be freezing. Okay, A. Now there's the B. Now what was freezing? Freezing is actually a liquid state changes to solid state when the heat is released. So it is liquid state changes to solid. Now come to B. See the arrow here. So now solid state changes into liquid. When the heat will be absorbed, the solid state will be changed into liquid, and now here it will be melting. Okay, students. Now come to the C. C portion is liquid to gas. Okay, liquid to gas. When the process in which the liquid changes into gas, when the heat is absorbed, the process is named as boiling or vaporization. Okay, moving on, vaporization. Next is D. This is deeper. The process in which the gas state changes to liquid state when the heat is released. Now, this is considered to be condensation, the process. Now, E. all of you see. E is gaseous to solid. What was that term we used, or the process in which the solid state changes into, in the process in which a gaseous state changes into solid state directly? That was deposition. Okay? And the process in which the solid state changes to gaseous state directly, that process is known as sublimation. Okay? So, this is the chart of interconversion of states of matter. Now, one thing is very important here, that how do heat absorbed and released, when the heat is released or absorbed, what happens at the molecular level? That also we will study. That will help you understand what actually happens. Okay. Hope all of you have understood this. Now, what happens when I say heat is absorbed and heat is released? Heat absorbed and heat released. Okay? Heat absorbed and heat released. For example, see here. When heat absorbed, we are talking, what happens at the molecular level? Consider this as an arrangement of solid particles. Solid particles, all of you know, the characteristics is that they are very closely tied to each other. When the heat is absorbed by it, okay, any solid body, heat is absorbed by it. Now heat is the energy. Now the way the energy is taken, to it already the kinetic energy is there. But as soon as more energy is taken, that in the form of heat energy, the molecules which are tightly packed starts to vibrate very fast. Okay? Because it has now a lot of energy in it. So, instead of vibrating at their mean position, the intermolecular force of attraction decreases between the molecules. Okay? Intermolecular force of attraction decreases. As soon as the intermolecular force of attraction decreases, the intermolecular space increases. Space increases. And thus, what happens? Due to this phenomenon, the solid state changes to liquid state, or liquid state changes into gaseous state, because the heat is absorbed, the energy is taken in. Okay? Heat absorbed means energy is taken in. Okay? Same way, consider now heat release. We now understand heat release. Consider here the molecules of water, that is liquid. Okay? Now, they have enough space now. Now, we take away, heat release means actually given out. Now, as soon as the energy is there, so they have a tendency, when the enough energy is there, it has intermolecular space also, and intermolecular force of attraction is less. It has enough energy now. Now, when you are taking the energy away from it, okay, you are taking the heat energy from it. So, what will happen to it? The molecules will become very weak, okay, and in that they will try to come together to each other, okay. Now their space decreases, that is intermolecular space decreases, and their intermolecular force of attraction increases, okay, that is intermolecular force of attraction increases. Okay. Due to this process, where the intermolecular space decreases and the molecules try to come together to each other, and intermolecular force of attraction increases, which pulls the molecules towards itself, okay, or try to attract the molecules towards itself. The molecules comes very close to each other, and in this process, heat release, that is energy given out, the gaseous state changes to liquid state, and liquid state changes to solid state. This is what is heat absorbed and heat release. Hope all of you have understood this. Because of the network issue and all, I was not able to complete this topic, which was very important. So I made a video related to this. I hope you all have understood it very clearly. And in the next class, we'll study the physical characteristics of solid, liquid and gas. Till then, thank you, all of you.